AI can write, create, manage, and adapt. But the latest banger from OpenAI says that they have given their GPT an ability to see. But how is that important, and what could it lead to? Let's find out. To start, it is very important that I provide you a base from where we can build up things. So that is why I'm starting this debate with the inception of this technology. The idea that a computer or a machine could see is often dubbed as computer vision. It involves capturing, analyzing, and extracting data from images to help computers comprehend visual content. Computer vision integrates techniques from AI and ML and relies on recognizing patterns, often using convolutional neural networks. But why do we need some systems? I will get back into the details of this later in this video, but for now, it's the amount of visual content that we consume daily. In today's internet-driven world, computer vision has made significant advances, with object recognition accuracy reaching up to 99%. It has applications in various industries, including manufacturing, transportation, healthcare, and sports. This field of research originally emerged in the 1950s and became commercially viable in the 1970s. Its importance is directly linked to the scale of automation we would like to achieve in the near future. The latest news came from the corridors of OpenAI, where they launched a new suite called GPT Vision, which integrates GPT-4 with image processing technologies. So, how can you use it? To answer the question about how you can use this, just open your phone and submit an image to the Chat GPT app for iOS or Android and ask it a question. With a $20 per month Chat GPT Plus subscription, send it a photo of your restaurant meal, for example, and ask, "How do I make this?" The chatbot will scan the image and return its recipe recommendation. According to OpenAI, multimodal is a key frontier in artificial intelligence research and development, as it broadens the spectrum of tasks that these systems can assist users with. Microsoft researchers dubbed GPT-4V the dawn of LLMs, concluding that it might give rise to new human-computer interaction methods. Now, to be honest, the first usage experience blew me away. I mean, it has a great capacity to tell about the images you may not want it to describe. In my initial foray into testing its capabilities, I decided to challenge ChatGPT by uploading a photograph of an intricately folded origami dog sculpture. This particular origami creation was none other than the one featured in the Meta AI keynote presentation by Mark Zuckerberg, showcasing some cutting-edge AI advancements. ChatGPT demonstrated its remarkable vision capabilities by providing a meticulous description of the origami dog. It discerned the complex folds, connected it to the Meta AI event, and even recognized the intricate details, such as the lion-like mane. It described the dog's almond-shaped eyes with brown irises against a plain, light-colored backdrop. The level of detail in ChatGPT's description was eerily reminiscent of a human observer. Eager to further test its abilities, I presented ChatGPT with a more formidable challenge. It was to analyze a complex logo. The logo featured a cheerful lemon character adorned with a virtual reality headset, a puzzling image that could easily stymie human observers. Yet ChatGPT astounded me once again with its ability to decipher the logo's key elements. It noted the vibrant yellow and green colors, identified the character's large, rounded head, and the oversized white goggles with dark lenses, along with a friendly smile on the lemon surface. It even recognized a leaf-shaped element protruding from the character's head. Despite not explicitly naming the object a lemon, ChatGPT impressively extracted a multitude of relevant details from this enigmatic logo. Now, it was time to test people. This is where I want to establish that ChatGPT's computer vision capabilities come with certain limitations. It cannot identify individuals in images or perform facial recognition, yet it can still provide descriptive attributes of people found in photographs. For instance, when presented with an image of Eminem, it delivered a remarkably precise breakdown of the rapper's appearance, down to his clothing, accessories, tattoos, and his intense expression. Even the surroundings were not overlooked. Then I tried to push the boundaries by uploading an image of Taylor Swift and inquiring about her identity. ChatGPT humbly admitted it couldn't directly identify individuals in photos. However, when asked if the person bore a resemblance to any celebrities, it humorously noted that the woman in the image shared striking similarities with singer-songwriter Taylor Swift, encompassing facial features, hairstyle, and makeup. Despite recognizing Taylor Swift, ChatGPT stayed true to its limitations and refrained from explicitly naming her. In essence, ChatGPT may not definitively name individuals in images, but it comes remarkably close to the edge of this constraint, exhibiting astonishing descriptive prowess and a deep understanding of complex visual content. The initial experience influenced me to dig into how these systems work. The answer was simple. The company fed it more and more complicated data, teaching it how to produce responses that humans appreciate, using the same technique as the text-based prompts, reinforcement learning from human feedback, which in the industry is often dubbed as RLHF. OpenAI claims that during this procedure, it came across enough flaws to postpone the feature's release because it was initially promised to come out in March. To its credit, engineers from OpenAI attempted to find methods for the system to fail or act unethically. This includes demands for dangerous or unlawful content, demographic discrepancies such as color and gender, and cybersecurity vulnerabilities such as cracking CAPTCHAs and jailbreaking. The journey did not end there. They asked for external help as well. With the help of external scientists and doctors, they tried to validate GPT-4V's suggestions, which revealed various mistakes. Upon initial testing, GPT-4V identified chemical structures and foods incorrectly. In terms of disinformation and societal harms, early versions of GPT-4V would wrongly comment on sensitive topics, such as whether or not to recruit a pregnant woman or someone from a specific nation. The technology would also fail to distinguish hate group emblems or destructive statements. After all this testing, OpenAI claims to have improved the system sufficiently for public usage, noting the fact that 97.2% of requests for illicit advice are now declined. Early GPT-4V versions also showed repeated ungrounded stereotypes, but the launch version declines the request. The process of improvement has still not ended, but it is still in the works. Users have also documented many accuracies. For example, a Microsoft study team discovered that GPT-4V improperly addressed several simple visual requests, such as misreading a speedometer. OpenAI claims that there are fundamental questions around behaviors the model should or should not be allowed to engage in. This includes whether it should recognize public figures in photographs and deduce race, gender, or emotions from people and images, and how accurate it is at doing so. They are also working on adding more usable language datasets, but so far it performs poorly in non-English languages. Like every other SaaS, GPT Vision also poses a great threat to privacy, as your data may fall into the wrong hands. The biggest threat is prompt injection, which basically refers to a technique for practice in the context of artificial intelligence and natural language processing, where specific prompts are used to guide or bias the output generated by a language model or AI system. Users can exploit GPT Vision to disseminate false or misleading information, enabling the spread of rumors, conspiracy theories, or fake news. Hate speech and harassment can be generated through offensive prompts, worsening online toxicity and harming targeted individuals or groups. AI can also be leveraged to amplify biases, reinforce extremist views, and incite polarization, contributing to social division and radicalization. Unethical marketing practices can use AI-generated content to promote fraudulent products or services, potentially deceiving consumers. Furthermore, AI can be misused for plagiarism and academic misconduct, undermining academic integrity, and it can be employed for identity theft and fraud, creating convincing phishing attempts and scams. Additionally, malicious chatbots can be developed to engage in harassment, spamming, and the dissemination of malicious content. Data exfiltration with code identical to the sample above is one of the only active use cases for the GPT-4 Vision prompt injection vulnerability. Currently, the code would have to run within the language learning module and should not be able to escape. To secure your data, remove any past GPT-4 or Bing AI interactions containing sensitive or secret information. Emerging technologies, such as these AI services, provide an ideal breeding environment for zero-day flaws that have never been seen in the wild, posing the constant threat of new and rapidly spreading attack types. If you use GPT-4 frequently, especially in a professional capacity, keep up to date on the present and changing threat landscape to avoid becoming a victim of exploited vulnerabilities. The onus is on OpenAI and developers who use GPT-4 and other AI services in their software development to prevent these attacks. To forecast and prevent as many vulnerabilities as possible, security-conscious decisions must be made throughout development and distribution. Subscribe to Innovella for more blues from the world of AI. Google has released a paper which is going to influence the robotics industry. So, are we now capable of making robots at home? To see what is happening, click on the video link popping up, and I'll see you there in a moment.